Good morning, Morgan, and good morning to any of Morgan's friends that are watching this video with us today. Now, today's video is going to be another short one. Don't have any code to run. We're just going to talk about something called a compiled Python file. Okay, what does that mean? Okay, so a computer only understands binary, ones and zeros. Okay, so when we write a program code, it has to be converted from that computer language into ones and zeros. Okay, that process is called compiling or translating. You could think of it as like translating from one language to another. Okay. Now, how Python works is that doesn't happen until you actually run the code. So the code is stored as a Python in the Python language, and then when you try to run it, it immediately translates it into a binary so the computers can understand it. A compiled Python program is just a Python program that has been pre-translated or pre-compiled so that it's stored in binary form. Okay? And all that does is saves a little bit of time that it would take to translate the Python language into the binary language. All right? And that might seem like not worth the effort, but there are cases in production when we're doing a lot of transactions when that will actually save you a lot of time. Okay, now with that explanation over, let's go ahead and do a little reading.
Python Training Video 32. Compiled Python files. To speed up loading modules, Python caches the compiled version of each module in the __pycache___ directory under the name module.version.pyc, where the version encodes the format of the compiled file. It generally contains the Python version number. For example, in CPython release 3.3, the compiled version of spam.py would be cached as __pycache_/spam.python33.pyc. This naming convention allows compiled modules from different releases and different versions of Python to coexist. Python checks the modification date of the source against the compiled version to see if it's out of date and needs to be recompiled. This is a completely automatic process. Also, the compiled modules are platform independent, so the same library can be shared among systems with different architectures. Python does not check the cache in two circumstances. First, it always recompiles and does not store the result for the module that's loaded directly from the command line. Second, it does not check the cache if there is no source module. To support a non-source, compiled-only distribution, the compiled module must be in the source directory, and there must not be a source module. Some tips for experts. You can use the O or OO switches on the Python command to reduce the size of a compiled module. The O switch removes assert statements. The OO switch removes both assert statements and __doc___ strings. Since some programs may rely on having these available, you should only use this option if you know what you're doing. Optimized modules have an opt tag and are usually smaller. Future releases may change the effects of optimization.
Okay. This thing, what are we doing with the -0 and -00? All right. All you're doing is you're telling the compiler to ignore the comments and just concentrate on the code. Okay? Unfortunately, this is a horrible idea. Okay? Whatever case there might be for you to do this, you will never run into it. Okay? And if you do run into it, okay, that one time, Okay? It's not going to make up for all the times you did it and it broke something. So my advice to you is ignore that and never, ever, ever switch anything off. Let's continue.
A program doesn't run any faster when it is read from a.pyc file than when it is read from a.py file. The only thing that's faster about .pyc files is the speed with which they are loaded. The module compile all can create .pyc files for all modules in a directory.
Okay. What they don't talk about is, okay, right here they go like, hey man, you got this file, you got this folder, and it's got all these modules in it, and you just go compile on, compiles everything. But what they don't tell you in this manual is how to just compile one. So I went ahead and found some example code. This is what you do. Import py_compile. Call the compile method or whatever. Here's the name of the thing. Here's the name of your file that you want compiled. Boom. And this is the output. That's how you compile one file. All right. With that, today's lesson is over. Go out and find something fun to do. All right? All right. See you in the next video.